Hi, I'm Josh Harris, and this is my response to Exam 2, Part 2, Stats 210, Section 220. Okay. In question 1, my example would be I would like to poll all current UK students and see what percentage of them like to play tennis as an extracurricular activity. So my population in this would be all of current UK students, and my parameter would be that actual amount of all the students that like to play tennis as their extracurricular activity. So I would take, let's say, 1,000 random people, poll them, and let's say I get a response of like 30% that do like to play tennis as an extracurricular activity. So my sample would be those 1,000 students, and my statistic would be that 30% of them that responded yes, that they like to play tennis as an extracurricular activity. So the difference between parameter and statistic is we usually don't know the parameter. That's what we're trying to figure out. So we take a statistic from the sample size, and we use that to sort of a representation of what the parameter is. As I would say, we know what the statistic is, and we use that as our representation. All right, in question 2, we have to build a confidence interval of parents that would like their child to be taught by a male teacher. Um, so what you do is you take first you find your margin of error. That would be z star over 2 square root of n. You would take your sample size of 567 and replace that as your n. So that would give you your z star, which is 1.645 over 2 square root of 567. You would work that out, and that gives you your margin of error, which is, I think it's 3.45%. You take your 15%, and you would plus or minus your margin of error, and that gives you your confidence interval. So your lower bound would be 11.5%, and your upper bound would be 18.5%. And that's what your confidence interval would be. And so what your confidence interval is telling you is that if you were to take, let's say, 100 different random samples, 90%, since we use the 90% confidence interval, 90% of those samples, so 90 out of those 100 samples, would fall between that interval. And we would assume those to be accurate to the parameter. If we were to increase our level of confidence, that would mean that our z star would increase, making our numerator increase, therefore making our confidence interval larger, because your margin of error would get larger, and it would almost, if you were to take that circle, it would make that width wider, and you would assume that more of your random samples would be inside of that interval. Now, if you were to decrease the sample size, that n under that square root, if you were to decrease that, that would make your denominator larger, therefore making your margin of error bigger, and that would also increase your margin of error, making that confidence interval bigger. So yeah, because seeing as your denominator got smaller, making for a larger margin of error. And that's just if nothing else changed and stayed the same. And that's my response for Exam 2 Part 2. Bye.